All right, welcome to video 1. In this video, we're going to talk about some things that you've seen in pre-calc, and that's why I'm going to go over them really quickly, because you should know this, you should have seen this already, as I said, in pre-calculus. Now, first of all, what we have here is a unit circle. A unit circle, a unit in math means 1. In multivariable calculus, you'll talk about unit vectors. Anytime you hear the word unit, that means 1. So unit circle has a radius of 1. Okay? Now imagine that this is on a coordinate axis, a Cartesian plane. So of course, this point right here would be 0, 0. This would be 1, 0, 0, 1, negative 1, 0, and so on. Now, one of the things you talked about in pre-calc was angle measures and radians around the circle. And we always start, we call this the polar axis, but we always start that this is 0 right here. This is 0 radians. And this is pi radians. Well, if this is 0, this is pi, that would make this pi over 2. And of course, this one down here then would be 3 pi over 2. Besides 0, you could also call this one 2 pi, because of course 1 time around the whole circle is 2 pi radians. Now, that's really nice, but sometimes it's helpful to also know some multiples beyond that, some unsimplified forms. For example, this isn't only just pi over 2, it's also 2 pi over 4. You see that of course would simplify to pi over 2. It's also 3 pi over 6. Okay, these are all equal, and I'll explain why that is helpful later. Of course, this could also be considered 3 pi over 3. It could be 4 pi over 4, because all of those would reduce to pi. I didn't write 2 pi over 2 because we don't really need that one. And down here, of course, we could do the same thing. We could have, let's say, 9 pi over 6, or something that would reduce to 3 pi over 2. Okay, so just knowing your way around the circle, that this is 0, pi over 2, pi, 3 pi over 2, back to 2 pi, radius of 1. So again, these coordinates, this one would be 1, 0. This one would be 0, 1. That's important to remember. Now, looking then at sine and cosine, which are the two we're going to focus on, because of course all the other trig functions we can get from sine and cosine. But remember that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Now, in our unit circle, if you think about our unit circle, we're going to start building triangles, and that's going to help us know what the sine of various angles are. But in our unit circle, any triangle I make, any triangle I draw, would always have a radius. It always has a radius of 1, so any triangle would always have a hypotenuse of 1. So if you can think about the fact that really in the unit circle, the hypotenuse is always 1. It really just becomes what's the opposite, and cosine becomes what's the adjacent, because it's just divided by 1. And that's going to help us quite a bit as we go around this circle. Now, let's start with a triangle, then we'll go back to some easier ones. And again, this you should have seen in pre-calc, but we're going to start with the two triangles that are going to help us build this whole thing. This is the 45, 45, 90 triangle. Now, of course, we don't often use, or really at all use degrees. We use radians. So 45 is pi over 4. So I'm going to name that pi over 4. Now remember, in our unit circle, we showed that the hypotenuse would always be 1 because the radius was always 1. So now we just need to find out what these two sides of the triangle are. Well, that's just Pythagorean theorem. Let's say we've got this side that's A. Well, then this side also has to be A because they're both the same angle, pi over 4 and pi over 4. So that means Pythagorean theorem, a squared plus a squared, or 2a squared equals 1. So a squared equals 1 over 2. So a equals 1 over the square root of 2. And of course, you'd rationalize this, and that's how we always come up with square root of 2 over 2. And they're both the same. Okay, they're both square root of 2 over square root of 2. Or I'm sorry, square root of 2 over 2. Now the 30, 60, 90 is a little bit trickier to get because we've got to do some building. And by that I mean we build another triangle like that off the side, and we say they're equilateral. So each side is 1. Well, if each side is 1, that makes this right here 1/2. So using Pythagorean theorem again, it's funny how we always come back to that. We've got that the height is equal to, height squared is equal to 1 squared minus 1/2 squared. So height squared, 1 squared minus 1/4 is 3/4. Take the square root, we have that h is equal to square root of 3 over 2. So now we have the height, and we also have, so we have all the sides of our triangle. Okay? Now, looking back here, let's start building with those triangles as we kind of go through the circle. Now, if I put a triangle up, let me do that. Let me put this one in here real quick. Here is the pi over 4 triangle. Now remember that the hypotenuse was always 1. Well, since sine is opposite over hypotenuse, but the opposite's 1, the sine is just going to be the opposite, whatever this side was. And this side we found to be square root of 2 over 2. Well, cosine's adjacent over hypotenuse, adjacent over 1, it's just square root of 2 over 2. And that's why we never really need to worry about the old definitions of sine and cosine here, because the hypotenuse is always 1. And what we find out, if you kind of pick that point right up here and you say, well, the y value gives me the sine and the x value gives me the cosine, you really think about this as a coordinate. You know, like I said, this was 1, 0, this was 0, 1. Well, this coordinate is square root of 2 over 2, comma, square root of 2 over 2. And what we find out, of course in this case they're both the same, but what we find is that since the adjacent is cosine, that cosine will always line up, I'm just going to put kind of an arrow there, to the x coordinate, and that sine will always line up with the y coordinate. And that makes our lives quite a bit easier, especially as you kind of go through the basic values at 0, pi over 2, and so on. Because we already knew that this point right here, this point right there, was the point, I'm going to write it right here, 1, 0. Well, that must mean if I asked you for the cosine of 0, since cosine matches the x-coordinate, the cosine of 0 must be 1, and the sine, which matches the y-coordinate, must be 0. And then we go up here and we say, well, this point in a unit circle, this is 0, 1. Well, it's pi over 2, cosine matches x, so the cosine must be 0, cosine of pi over 2, and the sine must be 1. And of course over here we've got negative 1, 0, so cosine of pi is negative 1 and sine of pi is 0. And down here at the bottom we've got 0, negative 1. The cosine of 3 pi over 2 is 0. The sine is negative 1. And that makes that really nice. But then we can also build, as I said, with these triangles, we could say that the cosine was square root of pi over 4 was square root of 2, and the sine was square root of 2 over 2. And we can go back and use our other triangle that we found. Remember that this longer side was square root of 3 over 2, and this shorter side was 1/2, so it has a y value of square root of 3 over 2 and a x value of square root of 3 over 2 and a y value of 1/2. Cosine square root of 3 over 2, sine is 1/2. And the beauty, of course, of that triangle is we can use it for both, because a 30-60 has the two different angles in there. So this one would have an x value of 1/2 and a y value of square root of 3 over 2. So the cosine of pi over 3 is 1/2, and the sine of pi over 3 is square root of 3 over 2. So that's kind of the easiest way to get started. Now, the tricky thing is, I guess, you don't want to build that every time. So what it becomes is memorizing probably these values right in here, because you notice that the pi over 3 and the pi over 6 triangles give you the same numbers, they're just flipped. So it really becomes memorizing some numbers. And that can be a little bit tricky. You should be able to just kind of use the unit circle to get the 0, pi over 2, pi, 3 pi over 2, and so on. But these two are a little bit trickier. So in the next video, I'm going to show you a real quick, easy trick of how to remember those values.